there. I've been playing around with some animations of snow in QGIS, and I thought I'd make a short video to show you how you might do this with your own map. So I'm going to start with a blank QGIS project, and down in the coordinates underneath the map, if you type in the word world, it will load in some standard country boundaries. And rather than having them float in space, I'm also going to add a layer underneath to be the water of the Earth. I'm not just changing the project background because later on I'm going to turn this into a globe and I want the sky to be or space to be a different color than the water of the Earth. So I'm going to use the grid tool, create grid, to create a rectangle grid that covers the whole planet. So I'm going to go from minus 180 to 80 to 180, and then minus 90 to 90, and I'll just do a spacing of 10 degrees. That should be sufficient. And I just want to make sure that my grid CRS is WGS 84. So this is latitude, longitude, so it's going to be covering basically the whole planet. And I'm just going to create temporary layers for this. So there's my grid. I'll move that to the bottom, and let's make that a nice water-like color. Nice blue. And then I'll also change my world map to not have that transparency. Bring this over a little bit. To not have a transparency, and let's make it kind of a green color like that. All right. And the next thing I want to do is to create our snowflakes. I'm going to use a random points tool, random points and extent. And my extent, I want it to go all the way from minus 80 to 180, but I want everything to start at the North Pole. I'm not going to put a 90 up there because I've run into some issues if you get too close to the pole. I'm going to start these around 80, and let's just say just put them between 80 and 81 degrees north, and let's do I don't know, let's do 150 points. And again, I just want to make sure my target CRS is WGS 84 so that this extent is in degrees. Okay, so I'm running that, and you can see here are my points. That's where the snow is going to start to fall, and I want it to move down the page. To do that, I'm going to be using a geometry generator. So in the layer styling, rather than using a simple marker, I'm going to change that to geometry generator. And with this, I could put a formula or an expression in here that changes this geometry. If you haven't used this before, you'll probably want to use the expression editor, which makes it a lot easier because you'll have your expression over here, and there's all these different functions in this middle column that you can use. All the geometry columns are in, or geometry functions are in this geometry section. And the one we want to use is called translate. If you click on any of these, you'll see a description of what it does. So this is going to offset it by some delta x and delta y. So I'm going to go to the beginning, and you can just double click on this and it'll pop it over there. So I'm going to translate geometry, and I'm just putting on this on different rows just to make it a little easier to read. And so I'm going to do that, just translated by nothing at the moment. One nice thing about the expression editor is that it gives you a preview, and it'll also tell you if you have an error in your syntax. But I'm going to go ahead and click OK just so I can have it show up over here, and I'll immediately see some things. So right now it's not showing, and that's because I need to make sure that this geometry type of this output of this expression is the right thing. So I need to make sure that's points. So there's my points again. Now if I change one of these numbers, like if I change this last 0 to a 40, it's moving it up 40 degrees, which doesn't really make sense because that's north of the North Pole, which doesn't exist. So I'm really going to want to decrease these by increasing numbers. So as I kind of change that, it moves down the map. Rather than do this by hand, I'm going to use the temporal controller in QGIS to increment these numbers. Now my random points, all they have in there is an ID number. So there's no other attributes that are needed. Instead, I'm going to go to the properties for this, and I need to turn on the temporal controller for this layer. So if you're looking at these other tabs, just make sure you select temporal, and then first of all check the box to turn on dynamic temporal control. And rather than using one of these configurations where you have a field that says the start and end time, we just want to redraw the layer. And we'll be controlling that location using that expression rather than a particular field in the layer. So I'm going to click OK on that and go back to our geometry generator. And so instead of putting -80 in there, I'm going to use function called epoch of the map start time. So map start time, it starts with a ampersand, and that's a built-in variable. When you're using the temporal controller, it's going to be the start of each frame. So first of all, I want to just turn on the temporal controller. I usually just right-click up in the empty toolbar area and go to not toolbars, panels, temporal controller panel, and I'm going to turn that on. And it doesn't really matter what the range is as long as you have plenty of seconds to work with. In fact, I'm going to change the step to be 1 second. And so I have the epoch of the start time, and I'm just going to multiply that by, let's say, negative 10 times that. Now the question is, where are our points? Our epoch is going to be a really large number because it's the number of milliseconds since January 1st, 1970. So I'm going to, that's a very large number of milliseconds. So I'm going to first of all divide that by about 10,000. It took me some trial and error to figure out this. But then I'm going to use this remainder or modulo operator. So basically I'll always end up with a number between 0 and 150. So here I can see I have my points. I'm going to click play on this, and you can see that the points are slowly falling. We're moving 1 second at a time, so to have a bit better animation, I'm going to go to the configuration for this, and let's do, say, 15 frames per second. So now I can see my points are falling based on this formula. Now when it hits 150 degrees offset, it's going to go back to 0, so they should jump back up to the top. So there we go. That will keep the snow falling continually. Right now it's pretty boring because all the points are falling at exactly the same speed. So we want to vary that a bit. First of all, I'm going to use a random number generator just to control the size of this marker. First of all, let's not make it red snow. Let's make it white snow. And instead of changing the size, all at once, I'm going to use a data-defined override for that. So I'm going to just edit another expression. And here, I'm going to use a random number function. So this is a random floating point number. Maybe I'll do a quick search in here for that. Rand_f, which will give you a random floating point number within the range specified. So the help in these expressions is really great. So you can see exactly what you need to put in for the min, max. And there's also a seed, which we'll find is really useful. So let's suppose I want these to go between, let's say, 2 and 10 millimeters. So now I have these, and yeah, they're between 2 and 10 millimeters, but they're changing every single time they're being redrawn because it's creating a new random number with every frame. So what I'd really like to do is go back to that expression and apply a seed. The only thing I have in my data table is the ID, so I'm going to use that, and that'll be consistent over the life of the point. So it'll always be the same size for a given ID. So now we can see we have random sizes, but they're consistent for each snowflake. So the next thing I'll want to do is provide a little left to right motion, as if the wind's blowing back and forth. So I'm going to go back to my geometry generator, and instead of it being 0, I'm going to use that same trick where I take the epoch of the map start time, divide that by 10,000. And this time I'm going to use a sine function, which will always give us a number between -1 and 1. So I'm going to take the sine of this. Right now, 1 degree oscillation is probably too small to see, so I'm just going to multiply that, say by, let's just really exaggerate, by 50. So you can see it's now moving back and forth quite a bit. Now they're all in sync, which is not how snow works, so what I'd like to do is add some variation within that. So I'm going to add a random number inside the sine function just to make sure that this, the left and right ends of each of these oscillations is different for each snowflake. So I'm just going to put in a random number, let's say between 0 and 10, and again based on that ID. Whoops. And I'll just add that to the epoch. So now it's a little hard to see because they're falling at the same speed, but they're all oscillating slightly differently. And maybe instead of having them fall at the exact same speed, I'm going to add a random number. So instead of 10, I'll do another random number, let's say between 10 and 30. And again, I always want to put in an ID number for the seed. So now that oscillation, or actually the speed they're falling is random, and I could even make that even more random, increasing that So some of the snowflakes are falling basically 5 times faster than the others because I have 50 and 10 for my limits of my random number there. Um, Another thing I might want to do is 50 is a little too consistent, so I'm going to change that left and right oscillation and also add another random number in there. Let's say between 10 and 20 degrees. So that's starting to look a little bit better. If it's a little too fast, what you can do is just change the step time. So I could say 0.5 and slow it down by half and just kind of fine tune that, make it a super slow snow or speed it up a bit. Um, So that's working pretty well. Now I did this in degrees because it makes it a lot easier for us to see these numbers and you don't have to count how many digits there are. If you could do this with a meters-based coordinate system, but you're just going to have to pay attention to like how many digits you have, and there are going to be some pretty large numbers in here. But I think in general you could stick with this, taking the epoch of the map start time, dividing by 10,000, and then just changing these numbers here that you're multiplying by. This one shouldn't matter too much, but it's basically these first two, this one and this one here, to just change the magnitude of the speed and the magnitude of that oscillation. Some other things you might want to do instead of using circles, we could use, here's not quite a snowflake shape because it's not hexagon based, but I could do something like that, and kind of looks like snow. You could find a better SVG or icon for snowflakes. So one thing you can do with this, instead of just showing on this kind of stretched out latitude longitude view, is change the projection of the project. And I'll do something like equal Earth at Greenwich, which gives us this kind of projection. And you can see the snowflakes are still falling. The locations are controlled by that function that's based on latitude and longitude. But it has the effect of kind of making the snowflakes kind of come out and then following the curvature of the map. And this can even work with a sphere-like view. There is a nice projection called the world from space. And when you do that, it kind of looks like a globe. One thing I found is that it doesn't, something weird happens with the animation. Most of the points seem stuck up here. And it's even worse if you started your points up near 90 degrees north. But occasionally a snowflake falls out. So this is a little weird. And one thing I meant to show back on this is that if I go back to I'll just do this one here. If I were to move this map, oh, look at that, it's working. If I were to go back to WGS 84, you'll notice that at some points the snowflakes just disappear, and that's because it only will draw the snowflakes, or it'll only draw those points if those original locations are within the map view. So they're just a little bit north of here, but once I kind of move the map down, now suddenly there they are. So if you suddenly have all your snowflakes disappearing, it's because the original locations, the actual point locations, are off the map, so QGIS doesn't even try to bother drawing them because it's just looking at the original locations and not this geometry generator. So just make sure those are in the map and you should be fine. But back here on the world from space, so we're having issues with the flakes not falling. Only a few of them are. One workaround I found is that instead of showing a symbol, we could show a label. In fact, I'm going to grab our function from the geometry generator and go to labeling, turn that on, and I can see there's my labels up there, showing them in the original location. But if I go to the placement tab and then go to geometry generator and paste that in, now my labels seem to be flowing nicely. They don't get stuck up there like the actual points do. So one thing I could do would be to turn off the original symbols, and let's make these look more like snowflakes. And this is where I might want to use a snowflake Unicode character. You could Google for this, and then just copy it from the page you find and just kind of paste that in. So there's a nice snowflake symbol. I probably want to make this a bit larger. Let's make it white. And there's a few things we'll want to do to kind of improve this view. They're kind of jumping around a little bit, and that's because it's trying not to draw labels that intersect with other ones. So I want to go to rendering, the last tab, and just make sure I show all labels, including colliding labels. So that'll help. And the other thing would be the placement settings. Instead of cartographic, where it tries to put a label usually off to the side of a point. We actually just want it on the middle of the point, so offset from point. There we go. So that's looking a little bit better. And maybe I can also add a size function here. So put in that random function, let's say between 4 and 12, and again put in that seed so the label stays the same size for each snowflake. This seems a little bit fast, so I'm going to slow that down. Something like that. Nice calming snow globe. Somehow it doesn't have that same issue with the points being off the screen. So I don't know if that's a factor of the fact that I'm using labels for these, but for whatever reason, it seems to work. Perhaps for this view, I might want a few more snowflakes, so I could have done more random points. That's easy enough to fix. You could just create a new set of points, and I think I was doing this around 80 and 81, and let's say 600 points. And just make sure you have your target CRS set to WGIS 84, otherwise this extent won't be right. So there's my points, and I can just copy the style from the layer I already set up. Go to Styles, Copy Style, all the style categories, and go to my new points, and just paste that style. I don't really need both of those unless I really want a lot of heavy snow. So there's that. It's pretty smooth. Maybe for this, I might even want to slow it down a little bit for a more soothing effect. Haven't quite worked out this issue around the pole. They just suddenly appear. It'd be really cool if they were all coming out of the hole or something like that. But I guess I could also move it like this and just have them off screen. Somehow that still works. So have some fun. Feel free to try it with some other coordinate systems. Again, you'll just want to pay attention to your digits here and make sure those are appropriate for the coordinate system that you're using. But doing in latitude, longitude, if assuming that's the direction you want the snow to go, you can always just reproject that. Although you might run into issues with some coordinate systems like the sphere view. So good luck and have fun. And I will leave you with a musical snow globe.